there. All right, today we're going to continue with what we've learned with logarithmic functions, and we're going to look at some properties that logarithmic functions have. Now, without going real in-depth with where these properties came from, because they really just are properties that can be derived through some simple algebra, today we're just going to tell you what they are. Go do a Google search and figure out where they come from, and if you're super curious. Okay, so there's three properties that we use when we deal with logarithms. And the first one says that if you are taking the log of a product of two things, in this case I'm saying x times y. All right, and I don't care what the base is. I wrote log base a. It could be any base whatsoever. But if I'm going to take the product or the log of a product here, I can also write that as a sum of two separate logs. And so what I'm doing is I'm taking that x and that y that I'm multiplying right here, and I'm separating it. We call that expanding it into two separate logs with that same base, whatever that base may be, but we separate it and add two logs. Okay, so for instance, I don't know that you have to write this in your notes, but here's what we're saying is that if I happen to have the log of 70z, let's say. Okay, so since I'm multiplying my 70 and z, that's the equivalent of saying the log of 70 plus the log of z. Now, the reason that we might be interested in being able to expand this is because this log of 70 that I have here is actually something I could just type in my calculator and get a number for. I could evaluate that log. And so that's the purpose of the expanding. Now, for right now, I just want to see that you can expand it. Don't worry about typing stuff into your calculator to get numbers. We'll just leave it like this. Okay, so let's look at these other properties. Now, this second property is very similar to the first, but instead of having x times y, we're going to have an x divided by y. So you're going to see some sort of a fraction going on. And you can separate that. You can expand that logarithm by making it two separate logs, and instead of adding your x and y, you're going to subtract your x and y. So very similar, but you subtract rather than add. All right, this last one is a log that has a power. So you can see that this y value here, that's to a power. Okay, so what happens with that y value is it actually gets pulled out in front and gets multiplied by your logarithm. Okay, and that's a pretty simple one to explain here, so I'm going to take a minute to do that. So let's say, for instance, that you have log of x cubed. Now, I'm always using just common log just because it's easy to write, but remember, it could be any log base anything. Okay, so log of x cubed, well, that is really the same as log of x times x times x. And from our first property, we learned that if you are multiplying things, then you can turn that into addition of multiple logs. So I could just call it log x plus log x plus log x. Now, typically, if I'm going to add the same thing over and over and over, I'm going to simplify that and say, well, that's really just 3 times log x, which is where this 3 is coming from. Notice here, when my y was my exponent, I pulled it out in front, and that's why you see it out in front. That's what's going on here. When you cube that, you really end up using that first property, and you're ending up multiplying it by 3. So that's why we take those exponents and pull them out in front. Okay, so let's keep track of those 3 properties, and let's use them a little bit. Okay, you're going to have to write kind of little here. I did not leave a whole lot of room here. So looking at this first one, I'm going to be expanding my logarithms here. So what I see in this first one is I see multiplication going on, but I also see this power, this exponent going on. So here's what I'm going to do. I'm going to start with that multiplication, and I'm going to expand it, and I'm going to write this up here. So this is going to be the natural log of 5, and remember, you can change the multiplication into addition of 2 logs. Okay, so we separated it that way. And then the other thing I'm going to deal with is that 2. Okay, that 2 is an exponent, so it needs to come out in front. Now it's only on the x, so I'm only going to put it in front of the log of x. All right, so then I would have natural log of 5 plus 2 natural log x. And I have expanded that. Okay, let's try our next one. Okay, this one's a lot messier, a lot more stuff going on. The first thing that jumps out at me that I have going on is this big fraction bar. That's that division. So let's start with that. So I'm going to have log of the square root of 4 plus x cubed. And since it's a division, I'm going to do subtraction with log of 12. All right, there's not much you can do with log 12 at this point, and so I'm going to leave it alone, but this first part is pretty messy. And the thing that I have to recognize with this is that square root. And you have to see that square root actually as a power. When you square root something, remember from yesterday that that just means you're taking it to the 1/2 power. So anytime you have a square root, you're going to think of it as a power and pull it out in front. So it's really a 1/2 log, and then make sure you keep parentheses around your 4 plus x cubed because you're taking the log of all of that. All right, and so now it would be very tempting to do something with this power here, but because we have this addition going on, this is kind of its own quantity. I can't pull just the 3 out. If you'll look at your properties, there isn't a property that says anything about taking the log of a sum, only when that's being multiplied, like it was right here on this problem. Then I can separate it. If it's being added there, I can't separate it. So I'm actually done. That's all I can really do with this one. Okay, why don't you pause the video for a minute and try this last one. See if you can get that one simplified, or expanded, I should say. All right, so let's look at this one. I kind of got it started for us. Now, if you'll notice, you're multiplying in there. You're actually multiplying 3 things. You got the 7 times the x times the root 5x. Now, if I were to guess, I'd probably say that you didn't separate your 7 and x, and you probably just wrote it as log base 3 of 7x plus log base 3 of root 5x, which is okay, but you got to keep going with it and separate the 7 and the x also at some point. So I went ahead and separated them at the beginning. So I actually have 3 separate logs since I have 3 things I'm multiplying. And then the other thing hopefully you caught was this square root of 5x is really like to the 1/2 power, so we needed to pull a 1/2 out in front of that term. Okay, I'm still not quite done because right here I have a 5 times x, and so I can expand that a little bit further. All right, so I would still have my log base 3 of 7 plus log base 3 of x plus, and I'm going to do it like this, 1/2, but when I separate this, this 1/2 is going to go on everything. So log base 3 of 5 plus log base 3 of x. All right, and then at that point, you could go ahead. I'm kind of out of room here, but if you have room, you probably are going to distribute that 1/2 so you can be rid of your parentheses on that, and just go with a plus 1/2 log base 3 of 5 plus 1/2 log base 3 of x. All right, now if you were getting really particular, you could probably combine a few like terms in there, but at this point, we've expanded it all. Let's go ahead and just leave it like that. Okay, so let's try going the other direction. What if it's already all expanded and we're trying to condense it down into something simpler? Okay, so let's do a couple of those. So you can see that it's expanded because I have logs, multiple logs written in there. And so if you look at the operations that you have a subtraction, so that's going to turn it into division. And then I also have this 3 here, which I know is going to have to go up on my x as an exponent. Now, I'm trying to condense this so that I can write it as a single log. So it's going to end up being a log base 7. And then I know that the 8 is going to be on the top. And on the bottom, I'd have the x, but remember that that 3 has to go up as a power on the x, so it would be an x cubed. And that's all there is. You're just condensing that down. Okay, why don't you try this next one on your own. Go ahead and pause the video. Okay, I went ahead and dealt with those numbers that were in front and put them on my terms as exponents. And so that would have been our first step. And some of you will be able to go ahead and just do this whole thing all in your head and just come up with the answer. Sometimes we can do that if there's not a lot going on. There was quite a bit going on here, so I went ahead and took a step to do that. My next job then is to get rid of this addition and this subtraction and turn it into multiplication and division. So then my last step would be a natural log, and I'm taking a square root of x times an xy, and then because of the subtraction, I'm going to be dividing by y to the 4th. And so remember, when you're condensing, you're trying to get it down so that there is only one logarithm, so I just have the natural log written once. All right, I could box that in, but there's just one thing that's bothering me there. I do see that this y here could reduce with this y to the 4th, so I'm probably going to go ahead and do that. The other thing, since I'm going to take one more step, typically when you're writing things with a radical, you would put the number stuff or anything that comes out nice and clean in front of it, so I'm probably going to do that at the same time. So what I end up with is a natural log of, on top, I'm going to pull the, well, I'm going to be reducing this y with this y to the 4th. And so really all I'm going to have is an x that goes in front, and then my square root of x. And on the bottom, I'm going to have a y cubed. And that's that problem condensed. Okay, so let's move on to something different. Now, we have been evaluating logarithms on our calculator, but we can only do common log, which is a base 10, or we can do natural log, which is a base e. And those are the only two that we've been able to do in our calculator. Well, there actually is. Not everything has those bases. So there is a way to go ahead and reduce or evaluate logarithms that aren't of that base. So let's look at this problem down here, this log base 3 of 8. Okay, so if I were to evaluate it, I know it doesn't come out nice. If I set it equal to 1, like if it was 3 to the first power, I would just get a 3, but it's bigger than 3, it's an 8. So if I did and evaluated it at a 2, well, 3 squared would get me a 9, and I have an 8, so it's smaller than that. So ideally, log base 3 of 8 is somewhere between a 1 and a 2. Okay, so that's a nice estimation of it, but I don't really know exactly what it is. So let's see if we can evaluate it on our calculator and get an exact answer that's somewhere between a 1 and a 2. Okay, so to do that, we have to use our change of base formula. And the change of base formula actually is derived from those properties earlier. Again, if it's really bugging you to know where that comes from, you can Google it. But here's the gist of it. If you are taking the log of any base whatsoever, doesn't matter, I call it a, of some value, you can actually calculate that in your calculator if you just take log, and notice I write base b, which means of a different base. I could use any base. I could say log base 7, but you know what I'm going to use is log base 10, because that's something I can do in my calculator. So I'm always going to be using common log here. I could also use natural log, but you know, common log is kind of common, so we use it. So if I do common log of x, which is this value here, and divide it by common log of a, which is the little base number right here, I can evaluate this. So on this example that we were doing, what that means is that if I want to do log base 3 of 8, all I have to do is log of 8, that bigger number, divided by log of 3, my little base number. And if I type that, and because it's common log, I can just type it in my calculator. When you do that, you have to be a little bit careful, because when you do like log 8, notice that it'll open up a parenthesis for you here. You've got to be sure to close that parenthesis before you divide. So divided by log of 3, and it is approximately 1.89, which is somewhere between 1 and 2. So that I feel good that we did that correctly. Okay, let's try a couple more. Okay. We could try to estimate it. I just kind of think that is smart to have some idea of what you're looking at. So log base 4 of 100, well, if I said it was 2, that would be 16, and that's too small. So 4 to the 3rd power is 64, so that's still not big enough. If I did 4 to the 4th power, it's 256. Okay, so 100 is below that. So I should be getting something between a 3 and a 4. Okay, so with that being said, let's go ahead and just type it in the calculator. You should be doing log of this bigger number here, we're just doing common log, divided by log of your little base number. Type that in. Don't forget to close your parenthesis on your 100. And we get approximately 3.32. Which is between 3 and 4, so I feel good with that answer. Okay, you try this last one. You should have gotten it to be approximately 1.86. Okay, so that's all we're doing today, is just working with some of these properties, doing some expanding, condensing, getting familiar with how to manipulate those logarithms. Good luck!